we get glaciers. And then those glaciers have the capacity to do a huge amount of, not to say damage, but change to the landscape. So these glaciers, they're warm, we call them wet. They're very steep valleys, so they're very fast flowing. In fact, outside of a few glaciers in Greenland, these are the fastest flowing glaciers in the world. And that means as they go along, they're changing that environment. The other thing that's happening here, of course, is, as I said, we have this external system, which is the climate, and that's driving those processes. As that changes, that too changes process. And so the other part that's happening here is that the snow caps or ice caps of the Andes are also losing mass, because as the climate warms and the climate changes, they rapidly use mass. And in fact, relative to the area that they occupy, they contribute proportionally the most to sea level rise that we've observed in the 20th century. Part of that is to do with how warm they are and how quickly they are moving, and also how big. So we've got two ice fields. We call them the northern Patagonian ice field and the southern Patagonian ice field. And the southern Patagonia is the largest of the two, somewhere around 13,000 square kilometres and around 5,000 square miles. So what's happening in here then is where our mountains are big enough to have ice, and we're going to see a lot of ice in the coming days, that ice is a really powerful agent of erosion. It holds onto the ground, it picks it up, it plucks it, it abrades it, and it moves that material. So it acts like a conveyor, delivering the mountain to our rivers that feed our deltas and then into the oceans. And so this process is described in the sort of bottom part of this diagram here. Right, as that snow accumulates, it's forced down and it flows. The rate that these glaciers are flowing is rapid, because in part, in Patagonia, they're flowing into water. Right, so many of you have been to Greenland and Iceland, and you would have seen these sort of surging glaciers before. What happens is, as soon as you put your ice cube into your drink, it starts to melt. And so these glaciers are always delivering material into either the ocean or into lakes on either side of the Andes. And so they lose mass really, really effectively in that way. So our environments then are shaped by whether there is glaciers there, but also whether there's been glaciers in the past. So you think of sort of the fluvial environment, the sort of V-shaped valleys that you would expect. When we have glaciation, those glaciers eat down the sides, so we get a U-shaped valley. We get over-deepening and truncated spurs, sharp points of arêtes and cirques as the ice carves into it. What that looks like in real life, this is one of the southern Patagonian glaciers. I took this photo probably about 10 years ago now, and I didn't file its name with the file, and I can't remember which one it is, so my apologies for that. But here we've got a classic example of what happens. Our ice has moved down valley and it's cutting away the material to make space for itself, and it flows directly into the ocean. And so we can see it's got that really nice stripe. Right, was it two stripes? Actually, there's one here, and there's one here. That's moraine. Basically, as the ice has converged, and it's converged from two tributaries, there's been a bit of rock in the way. And so it's ripped that rock and smeared it downstream with it, all the way to its terminus. So these sorts of glaciers, as I said, they're really fast. Now I think at this point you're going, you've said this already, how fast is fast? Well, bear with me, it's a glacier. Right. You're going to be able to outwalk it. So this, the fastest glacier in the northern Patagonia icefields flows at about 7.6 kilometres a year. Right. That might not sound like much, but that's about 20 metres a day. The fastest, what we know of that we've measured in Greenland, is about 15 kilometres per year. And that's as fast as they get. In southern Patagonia, they're about 10 kilometres per year. So a little bit slower. I think that's a race I could probably win. So depending on weather and depending on a whole bunch of things, we might have the opportunity to see some things as we go through the Straits of Magellan and the Beagle Channel. And if we are able to see that, the reason why I'm being really coy about this is that whenever I go anywhere in the world, if I want to look at cathedrals, it's under scaffolding. When I walked the Inca Trail and got to the peak view, the beautiful vista at the top, I had 2 days of hiking, covered in fog. So we take everything with a bit of good fortune and see what we will see. We'll see relatively close to the ocean, so this is marine water at the bottom here, these sorts of landscapes where we have our ice, and here's our little ridge at the top, and it's sort of sitting in a bowl. And then we've got some bare rock, here's a waterfall, and then another sort of bowl at the bottom. That bowl at the bottom is where that glacier used to be. And I'm not saying recently, because obviously we've had soils form and trees since. So that's reasonably happened over about 10,000 or so years. But where we see the ring of denuded rock at the top, that's where it has pulled back in recent time. And so you can see that perhaps really clearly on this one. It's almost like a halo around it, or I guess like a paternoster hat. And that tells us that the environment is changing, right? For the last million or so years, Patagonia has been ice-locked. And we think of that million or so years, around 800,000 or 80%, it was fully ice-covered. Now, of course, there's change in the environment that happens over time as well. As I said, about 10,000 years ago, 12,000 years ago, we got to the end of the last glaciation. And our glaciers have pulled back from their maximum extent. And that's why we get to see some of these fantastic types of environments. And we see the temperate glaciers, the big waterfalls that form in those places. But where we've had complete deglaciation, and to be fair here, the deglaciation is what gives us the Straits of Magellan and the Beagle Channel. We get these environments of fjords, submerged valley systems. And when it's carved into metamorphic rocks, they keep their shape. We get our U-shaped valleys and hanging waterfalls. So that tells us that that's what our environment used to look like. And so where we've had complete deglaciation in our fjords, this is what we get. Well, there's plenty of places around the world that look like this. Scandinavia, Patagonia. One other place, can't remember. New Zealand. So, the other part to that, I guess, to think about it is I've been talking about the glaciers because I'm building up to how Antarctica works as well. But for the environment in around Patagonia, it's not just about the big valley systems. There are also the eastern landscapes where they're sort of undulating and hummocky, where we've had old moraine forms, lots of peat formation and lots of bogs. And they said that's also part of that broader environment and how it's formed. This is the flight out from Ushuaia. Said I'm the most annoying passenger on planes. Look at hogging the window. And just to sort of wrap up a little bit here, I guess the key thing is that when we're thinking about how a place looks and how perhaps we feel about a place, we're observing processes that have happened over a long time, and they are dynamic landscapes. And so we can see clues of the past. And mountain building happens extraordinarily slowly, 20, 30 million years. And how quickly they're taken away from that environment will depend on how high those mountains are, how cool that environment is. So if we change the atmosphere, we change the rate of process. And just to give an example here, this is a collection of observations of climate stations across sort of the northern part of the Andes. And so what they've done is they've aggregated those temperatures, they've created a median line, and that's the median temperature between sort of, for the 20th century, 1961 to 1990. So that's that dashed line. And then what they've done is they've plotted the mean temperature as a deviation away from that. And this is what all climatologists do. So it's not an actual temperature, it's what we'd call an anomaly, a variation away from it. And so if you look at that relative to that mean, we see in the northern Andes it was a little bit cooler than the mean through to about the 1970s, and perhaps a bit warmer than the mean from the 1970s onwards. And so that has a big impact in driving those rates of retreat and how much is being lost across all of the Andes, how high those snow lines are. And that has some impact and implication for the traditional peoples who live in the Andes, who have relied on that water supply to sustain their communities. As your glaciers get less, as your snow retreats, you have less water, right? It may all come out in one big lump, which is no good to you. And so that has some challenges. In terms of Patagonia, as I said, we're looking at a relatively important contributor to sea level change. And that rate of contribution is accelerating. So much so that for the period between sort of 1961 through to about 2016, we're looking at about 3.3 millimetres of sea level rise alone comes from those Patagonian ice fields. Now I know 3 millimetres sounds like nothing, but it is an important element of a bigger puzzle that we're trying to resolve. So they're rapidly thinning, they're losing a lot of ice, and that landscape is changing because of it. So there's some things that I'll talk about throughout the lecture program on the during the cruise. What I'd like to say is that if you have questions, we're not going to operate questions in here because, one, I can't see you, and it might be a bit tricky. Two, there's something more fascinating and interesting coming on after me. So what we'll do is, if you've got any questions, you want to have a chat, I'm going to head to Gatsby's, and I'll probably be there for about an hour or so. You can come along, we can ask some questions, and we can go from there. Right, thank you very much. I hope you all took good notes.
Good afternoon, everyone, and welcome to this presentation. It's really good to see so many people turning up, and I hope you're excited about this journey. I mean, we're getting further south, we're getting nearer and nearer, and I hope you're excited about going to Antarctica. I guess, yeah, good. I mean, there's probably people who've been there before. Is anyone prepared to admit they've been there before? Anyone been? Any hands up in the audience? maybe not. I know there's one or two people on board who came last year, and they loved it so much they've come back this year, so that's really encouraging. And I'm one of these people who, I've been coming to Antarctica now for over 40 years, and I'm always excited about heading south on a ship, heading for Antarctica, so I'm certainly excited about where we're going. And today I'm going to give you a sort of general introduction to what Antarctica is, where it is, what it looks like a little bit, and the kind of things that we might see. So it'll be a sort of a general overview, both of the continent itself, the geography, the biology, the politics a little bit, and the kind of experience you get when you go down on a ship like this. And so it'd be quite general, and actually it really just introduces some of the subjects you'll hear from the other lecturers about. They're far more expert about some of these things than I am, and so I think it's just nice to introduce all these subjects in one talk, and then you'll get the sort of details from Craig and from Sarah and from Rodrigo, whose talks I very much recommend you attend. In fact, actually, I have to say, I didn't speak a word of Spanish, but I came to Rodrigo's talk about the southern oceans this morning, and I could understand most of it. He had very good graphics, and it was really interesting, so I'd actually recommend his talks as well, even if you don't speak Spanish. So let's crack on. Let's just start about thinking where we're going. We're going to Antarctica. Now, these are two views of different ends of the Earth, and they illustrate the difference between the Antarctic and the Arctic. Okay, probably quite a few of you. I know you had a big cheer for Iceland earlier on today, I think, or was it yesterday? So I know some of you have been up north, and maybe not so many down south. So north, the Arctic is basically an ocean. And you can see it on the left here. The middle of that map is the Arctic Ocean, and the North Pole is somewhere in the middle of that. So you've got basically an ocean surrounded by land, which has a very certain biology. And with Antarctica, you've got a continent, a land mass surrounded by ocean. So that makes them immediately completely different in so many different ways. In the Arctic, you can pretty much walk there. You just sort of walk north from some point in Canada or somewhere, and you just keep going, and you'll eventually arrive at the North Pole. It's not quite as easy as that, by the way, but you can, it can be done and has been done. With the Antarctic, you really have to use a boat, because you've got to cross this ocean, and the narrowest place to do it is between the bottom end of South America and the Antarctic Peninsula, which is the way that we're going. We're somewhere here at the moment. We're heading down to there, and then we'll cross the Drake Passage and head for the northern end of the Antarctic Peninsula. So let's just have a slightly closer look at Antarctica. Hang on. Oh, there we go. So traditionally it's divided into two sections. There's a larger section on in the right of this picture called East Antarctica, and a smaller bit called West Antarctica on the left. Now, if I'm absolutely honest, it rather depends on which way you look at it as to what you decide is East and West. It's a little bit academic, but anyway. So they're divided by a mass of the transantarctic mountains there, and so you've got this big mountain range going across the middle, and this area is basically one massive great ice cap over there, and this is an area much more mountainous, and the mountains extend right the way up along the Antarctic Peninsula, and these are actually an extension from the Andes. So if you saw Sarah's talk this morning about the Andes Mountains, which come right down to the bottom end of South America to Patagonia, in fact that arc of tectonic plate extends right around past the island of South Georgia there to the South Sandwich Islands, and you can see that sort of curve as is marked on the map. That's basically underwater mountains plus a few islands, and then that continues down along the Antarctic Peninsula. So the Antarctic Peninsula is basically an extension of the Andes Mountains. And one reason that we tend to go there, that is basically the Antarctic Peninsula is the area which is most visited by tourists. And I would say about 98% of tourist visits to Antarctica are to the Antarctic Peninsula. And that's really because it's got the closest landmass, so it's easiest to get to. So you come across from South America at 600 miles across the Drake Passage. Whereas if you want to come to another part of Antarctica around here, you have to come from either wherever it is, Australia somewhere there, I think, lurking off the map, so you have to cross a much greater bit of ocean, or South Africa you can go from over there and you have to come right across there. So this is obviously, this southern tip of South America is a very good access point. But the other reason for going to the Antarctic Peninsula is because crammed into a relatively small part of Antarctica is sort of huge riches in terms of scenery and in terms of wildlife. So it is one of the most extraordinary and beautiful parts of Antarctica. And one of the reasons for the wildlife is because there's a lot of exposed rock down near the coast, and so animals like penguins can come ashore and they can breed on the coast, and so you've got this massive wildlife that uses the landmass of Antarctica. Now, one thing about the wildlife in Antarctica is they only need land to breed. Most animals are marine animals. They are dependent on the marine ecosystem for food, and I'll talk a bit more about that later. But you can see why, because it's basically it's surrounded by sea. In winter it all freezes over anyway, and so the only food source is in the sea. So they're all sort of animals that rely on the sea for food but come ashore to breed. And that's a sort of critical point about the wildlife. So let's have a look at some definitions of what is Antarctica, which bits are Antarctica, can you define it? There's a landmass there, but there's also lots of offshore islands. As you'll see in a minute, the whole continent expands at one point in the year and then contracts again. So how do we define Antarctica? Well, we could say, let's say Antarctica is all the landmass inside the Antarctic Circle. Which is a geographical circle you can put on the map about there, 66 degrees, 33 minutes and 49.8 seconds south. And the Antarctic Circle is defined as the point north of which you, hang on, wait a minute, let's get this right, south of which on the longest day of the year you will see the sun 24 hours a day. So the sun will stay above the horizon, and in winter it'll stay below the horizon for 24 hours a day. But as you can see from the map, that actually cuts off quite a lot of landmass, including the bit we're going to up there. And actually this map's not quite accurate, but the Antarctic Circle doesn't actually include quite a lot of promontories sticking out on this part of Antarctica as well. So although geographically and sort of astronomically it's an important circle on the map, it's not in a sort of practical, it's not a very practical definition of Antarctica. So for many years now, the definition of sort of Antarctica has been 60 degrees south. And 60 degrees south, which is this map here, that dark black circle there, and that encompasses all the Antarctic continent plus the Antarctic Peninsula and the South Orkney Islands and the South Shetland Islands. Outside that, there are a number of islands all dotted around here which are claimed by various countries like Australia or South Africa or the UK, in that case of South Georgia up there. And all these islands are sort of sub-Antarctic, and they're sort of politically they're outside the Antarctic region and outside the definition of Antarctica. But they very much lie within the biological area of Antarctica, because the biological area of Antarctica is defined as all the area within an area of cold water ocean that surrounds Antarctica. So let's have a look at that, and that dark black line defines the Antarctic convergence, which is where the cold water of Antarctica meets warmer waters further north. And the cold water is the sort of critical bit which drives the biological diversity and the sort of basically the quantity of wildlife that you get in Antarctica. Just very quickly about the rationale of here we are, we've got the Antarctic convergence just marked on the map there. I'll talk a bit about the Antarctic convergence later on, actually, about why cold water is important in Antarctica. Now, when I said the whole continent sort of grows and then shrinks again, is actually because during the winter it does change dramatically. So in winter the sea is so cold that it freezes, and it freezes out from the Antarctic continent. And the map on the left here gives you a sort of, I mean, you know, it varies over the years, to be honest. It gives you an extent of the sea ice that forms during the winter. So this is only temporary ice, but it does effectively, as you can see, effectively double the size of the Antarctic continent for a few months of the year. So that ice is just basically frozen sea, and it freezes out, and then when the summer comes along and it gets warmer, the sea ice breaks up and shrinks again to roughly the sort of areas you can see on the left here. Now there's some pale grey areas in here. You can see that one there, a really big one called the Ross Ice Shelf, and the one there. And these pale grey areas are also floating ice, but they're ones that are permanent and don't melt during the summer. So the sea ice obviously expands from them, coming out here, but then it melts back to them. But you get a sort of ice edge, which does change, obviously, but basically that's a big floating area of ice in there, which is fed by glaciers coming down from the Antarctic continent. So there's sort of permanent ice, there's sea ice that comes in the winter and then goes away in the summer, and then there's all the continental ice stacked up on top of this continent. Let's have a few kind of extremes. Antarctica is an extreme place. It's one where you can't really imagine this, but it's actually, the Antarctic is actually a desert. It's a cold desert. Okay, you think, well, it's got all that water in it, but actually it has very low precipitation, and so it is in fact a desert. So we'll have a look at a few. Hang on, pointing my finger the wrong way. It's obviously the coldest continent on the planet. It's one of the coldest places on Earth. Coldest temperature was about -89, measured at a station called Vostok, which is way up on the plateau in East Antarctica. And so it gets very, very cold indeed, and it's cold most of the year round up there. Round the coast it gets much warmer, and in fact the sort of temperatures in the middle of summer that we're going to experience, probably not much. I mean, if we get below freezing, it'll be unusual. It might be between 0 and 5 degrees, something like that, around the coast of the Antarctic Peninsula in summer. So don't panic, okay? You're not going to need, you know, the great big sort of Michelin suit for sort of massive padded stuff. You need some cold weather clothing. When you're out on deck, you're going to need some gloves. You'll need a hat, something like that. But you can always, on the ship anyway, you can always pop indoors and warm up. So don't panic. You're not going to freeze to death or anything like that. So it's also the highest continent on average. And that's because you've got this incredible build-up of ice. I mean, most of that height is just a massive great block of ice, which gets up to about 5 kilometers thick, which is 3 miles. So in the middle of Antarctica, you get, if you're standing on top of the ice cap, you've got about 3 miles of ice below you. So it's an immense volume of ice. And so it is actually one of the highest continents as an average height. It's also one of the windiest. And that's because you get these, because you've got a huge cold continent and you've got warmer air all around the side of it, and so you get a differential sort of pressure systems and differential temperatures, and that creates a lot of wind. And it's also, as I was just saying, the driest, which does make it a cold desert, technically. So those are the sort of extremes, you know, the coldest, highest, windiest, driest. A sort of slightly odd combination of things, really, in a way. And as I say, when you think of all that snow, it's all water, but actually it's frozen, and there's not much adding to it every year, which does make it a desert. So if you take a sort of bit of it's almost a cartoon view of a cross-section through Antarctica, the actual landmass goes up and down significantly, and this is the brown bit at the bottom of this image, and you can see actually some of it's below water. I mean, it's below the sea level. Sorry, not below water. It's all below water because it's covered in ice. But that's sea level there, and you go across, and actually these bits and some of those are just about below sea level. So if all the ice melted, you'd actually have a series of islands. You'd have one big land mass and lots of little islands dotted around the place, and it wouldn't look anything. The map would look completely different. In fact, a lot of things would look different, which we'll come on to in a minute. But you can see why it's, on average, the highest continent on Earth, because you've got this build-up of ice, this huge ice cap, 2,000 meters, that's about six and a bit thousand feet, for quite a long way across there. So that, the average depth of that's quite big. The average height is incredible. You've got some mountains which go just above the height of the highest bit of ice cap. So these Antarctic mountains are pretty big, and yet there's some areas which are very low around them. So the actual sort of under ice geography is quite dramatic and quite extreme, and more so than you might think. You just think it's just a great big bloop of ice, but actually what goes on underneath is quite varied. If you get a closer look at the Transantarctic mountains, they're actually quite impressive. They go up to that's about 15,000 feet, I think, and these are some of them. That's a particularly spectacular rock face. These are pictures from a friend of mine, for which I'm very grateful. But that's a 5,000 foot or 1,500 meter rock face, just one big slab of rock. So as you can see, and again, if you were at Sarah's talk this morning about how mountains are formed, there's been some pretty serious forces cutting out these mountains. Big glacial pressures of kind of just carving away at these rocks and creating these spectacular peaks. The highest mountain in Antarctica is Mount Vinson. It's just around 16,000 feet, as I said just now, 5,000 meters. That's it in the background there, behind a field camp. And in fact, it's interesting, just one little note about this picture is that the field camps, they still use these old-fashioned pyramid tents, which are pretty much what Scott and Amundsen and people used in the old days, and they still use them, partly because they're a really excellent design. They're not exactly lightweight. You have to have, they're made of very heavy canvas with very heavy poles and all the rest of it, but they do stand up, and once you've got it standing, because they're pyramidal shaped, it doesn't really matter which way the wind's coming from, and you can be quite snug inside them. So that's a couple of very old-fashioned looking tents, but they're very solid. I think the British Antarctic Survey still uses them. Okay, we've got all this massive ice on top of this continent, and let's have a look at some of it. So, if you go up on top of Antarctica, I'm not, again, this is not my picture, a friend of mine gave me this one to use. This is a picture, and you think, well, what's the perspective here? Are we standing on this, or are we looking down at it from space, or what? And Antarctica does a little bit do that to you. Distances and scale is often very confusing. This particular image is taken from an aircraft about 1,000 feet above the surface. So you're looking down on this big ice cap, and you can see it's not particularly flat. Imagine if you were skiing across there or pulling a sled to the South Pole or something like that. It's actually quite bumpy, and it can be quite difficult terrain. So, a pretty obvious question is how much ice is there? And from all the pictures I've showed you so far and the numbers and the kind of illustrations, there's quite a lot. Okay? If you want to put that in numbers, which frankly mean almost nothing, they mean something, but 28 million cubic kilometers, well, I think I'd have a bit of a job trying to visualizing exactly what that is in terms of Olympic swimming pools. For about 4 trillion, it's for the imperial minded, it's 7 million cubic miles of ice. So that's a lot of ice, and let's have a look at what that means in terms of sort of global ice amounts. So it's 98% ice cover over the continent. So most of Antarctica is just covered in ice. without any bare rock. Most of the bare rock that you see either sticks up in the transantarctic mountains or is down by the coast, and is where it's warmer. So and you get these rocky promontories sticking out, which are the ones where the penguins breed, and the area which makes the Antarctic Peninsula so diverse in wildlife. But most of Antarctica is covered in ice. It's actually contains 90% of the world's
Ice.
sort of constant ice, basically. Most of the other 10% is the Greenland ice cap. So the Greenland ice cap is also fairly massive. And then there's other bits, like the Patagonian ice caps, there's bits in the Himalayas, the Alps hasn't got much left, Alaska's got a few bits and bobs. So there's various other bits of ice around the world, but mainly it's Antarctica and the Greenland ice cap. They are the two biggest ice caps, of which Antarctica is, well, 9 times bigger, pretty much. So it's a very, very significant ice cap, and it also contains 68% of the world's fresh water. So that's of all the fresh water in the world, including the rivers and lakes and everything else. So it's a very high percentage of the fresh water in the world. I think about 20% of it, much of the other, no, about 16 or 17% of it is actually in Lake Baikal, apparently, in Russia. So that contains another large quantity of the Earth's fresh water. The average thickness of Antarctica ice is 2,300 meters, which is 2.3 kilometers. That's about 1.3 miles, something like that, the average thickness. And where are we? Maximum thickness is 5,000 meters roughly, which is about 3 miles. So you've got about, you've got about 3 miles of ice under your feet, where you're standing right on top of the Antarctic plateau. Right, that's a different picture as a background, but a few more icy facts. What if it all melted? Whoops. And it's kind of a question we need to ask ourselves these days, for obvious reasons. If you just do the math, as they say, the sea levels would go up by 60 meters. That's about 200 feet. So if all of Antarctica melted, the world sea levels would rise by 200 feet, or 60 meters. That would cover most capital cities in the world. It's the sort of time where you'd want to be living in somewhere like Bolivia, where La Paz is, I think, 10,000 feet up. And so you'd be fairly safe up there. But many of the other ones, including, London, New York, the whole lot, Sydney, that sort of thing, Auckland, I think we've got some New Zealanders here. All those ones, Buenos Aires, that'd be underwater, they'd be just gone, most of them, if the sea level rose that much. But it's extremely unlikely that the whole of Antarctica melts, so you're okay. However, let's imagine that only 1% of Antarctic ice melted. Then we only have 1% of that sea level rise, which would be 0.6 meters, which is about that much, okay, off the stage. So if the sea levels rose by about 2 foot, you'd think, that's not a problem, until you realise that 150 million people would be homeless. So we would have a problem. So Antarctic ice, it's very important that we keep it in Antarctica by what we do around the rest of the planet, which I'll have a chat about in a minute. Without wanting to be too dismal about it, let's look on the bright side. Ice is really beautiful stuff. You can see the background to that picture. That was a chunk of black ice, which I photographed a few years ago. And ice, everyone thinks of what colour is ice? Ice is white. No. Ice is almost any colour you want to throw at it, or any colour that reflects or refracts through it. And it can be amazingly varied, and I just love photographing ice, and I love looking at it. It's very, very beautiful stuff. This is a picture I took for National Geographic a few years ago, and here you've got this sort of white uncompressed ice and then some black ice, as we call it black ice. In fact, it looks green because of the ice, with the light reflecting through it, and it's got these amazing sort of green stripes through it. So I think one thing I would say is on this trip, we've got about 48 hours when we're going to be in Antarctica. Make the most of it, enjoy it. Just be out there as much as you can. Keep an eye out. You never know what time of day. You know, different times of day the ice looks different. And if you're going past an iceberg,
Từ
or
cái phòng
past,
mình đi
you
ra
know, some beautiful
Internet
mountain
Cafe gần
scenery,
xích
and it might be, you know, this was about 11 o'clock at night. And we got this beautiful sunset, and the sun came from just very sort of, you know, at a very shallow angle. You got this lovely sunset one way, and the sun was, rays of sun were lighting up this wall of ice, and it's incredibly beautiful. So, however much you might be partying at 11 or 12 at night, do keep an eye open out the window and just see what's going on around you. Just for those 2 days, you won't regret it. Yeah, there may be something happening. It's just a lesson for every time in Antarctica. You know, every time I sort of think about, oh, I must just go to sleep, there's something amazing happens, and you sort of think, no, I can't go to sleep because this is incredible. And that's, you've got 2 days of that. So I really would encourage you to embrace it. One of the key features about Antarctica is not just the ice and the mountains and the scenery, it's the wildlife, and I'm sure that's why many of you are going. So I'd just like to do a very quick introduction to some of the wildlife that is in Antarctica. We won't see all of these things, but I'd just like to, you know, give you a sort of bit of a view of some of the kind of wildlife highlights. This is actually a humpback whale tail, and we may well see some of these. I'd say this is very likely, because the whale numbers in Antarctica have been increasing over the last few years. They're actually really impressive at the moment, and in the middle of the summer, which is where we are now, is a very good time to see them, because humpback whales come down to Antarctica to feed in the summer, and so you just get this fantastic concentration, especially in some of the areas where we're likely to visit. So humpback whales are one thing we might well see. Now, just going back a couple of subjects, back to this comment that everything is dependent on the sea. So all these animals feed at sea and are dependent on the marine environment. And the marine environment is really important because A, it's kind of huge, it's all around Antarctica. It's also cold. And so you've got this huge mass of cold water. And you might think, well, cold and that far south, it's really unproductive. But actually, cold water contains more contained gas than warm water. So cold water has a lot of carbon dioxide. And also in the summer, it's got nearly 24 hours a day sunlight. So you've got masses of sunlight, masses of carbon dioxide, and that's exactly what plants need to grow. And you think, well, hang on a minute, he's talking about the sea, we're not talking plants. Well, actually we're talking phytoplankton, which are like plant plankton in the sea. And they thrive in these long summer days with lots of carbon dioxide in the water, and then so the things that eat them do very well, because there's suddenly a huge blooming of phytoplankton, and that feeds this little animal called a krill, which is a shrimp about that long. And pretty much, I mean, it's an incredibly simple food chain in Antarctica. It goes phytoplankton, krill, everything else, okay? So krill, and you get billions of tons of it in the Antarctic Ocean in the summer, is basically the food source for most things in Antarctica, for whales, for seals, for penguins, for albatrosses, with a bit of variation. And some of them use fish as a kind of intermediate, so fish will eat krill, and then some of them eat fish, and squid do the same. So, but krill, you know, phytoplankton and krill are the basis of this very simple food chain. And that's because it's, as I said, because it's cold. In winter it all packs up. In winter there's very little sunlight, and the krill all go like this and kind of sit under the ice, and nothing much happens. And then summer they suddenly go woo, and they're all out again, and they start breeding like mad, and it all goes off again. So it's very much of a seasonal cycle. That's why everything goes to Antarctica in the summer. That's why penguins breed in the summer. That's why whales go there in the summer. It's why, you know, the whole thing works in summer. So here's another humpback whale, just because I like pictures of humpback whales, and they're one of my favourite animals. They're completely amazing, and as I say, we should be able to see some. The other marine mammals that we have down in Antarctica are seals. So, for example, we might get a weddell seal. You might see one or two of these on an ice floe. They're not common. I mean, there's plenty of them, but they're not that easy to see from a ship. But weddell seals are quite an important feature in the Antarctic ecosystem, as are crab-eater seals. Crab-eater seals are actually one of the most numerous large mammals on Earth. So pretty much second only to humans, actually. But you only ever see a few at a time. You might see a group of them on an ice floe, like there. I think they're mainly crabby seals. Yep. And occasionally you might get a Weddell seal in amongst them or whatever. So it's always worth keeping your eyes open for ice floes. You never know what you might see on them. Now, one of the other seals we probably won't see, but which is very numerous as well, are elephant seals. Hang on. Which are very distinctive. They've got these really big noses. You get a northern elephant seal, which occurs in California, and then this is the southern elephant seal. You get around some of the sub-Antarctic islands, but they also go down to the Antarctic Peninsula to molt later in the summer, and about this time actually. So if we get a view of some beaches, you never know, we might see one or two of these. But the really crucial thing about this is they illustrate how rich the Antarctic environment is in terms of numbers, because this ocean just supports vast numbers of animals. And so just elephant seals alone, if you ever get the chance to visit South Georgia, you might see something like that. You get these enormous numbers of elephant seals. And I was privileged in my time as a scientist to be involved in a survey of these animals where we counted every single beach, the elephant seals on every single beach right around the island of South Georgia. And we sailed around it twice in a sailboat, and it was an extraordinary thing to do. And in fact, while we're on the subject of South Georgia, another animal that really illustrates the richness of the place, penguins. And again, we won't see these. These are king penguins on South Georgia, but it just gives you an idea of the sort of numbers that the ocean can support. Some of you who get to Falkland Islands may be going on tours, and in fact, one or two of those tours do visit king penguin colonies. One penguin that we might see, this is the Gen 2 penguin, very distinctive because it's got a white patch across the head and a red beak. We may see these either on ice floes or on the shore if we get in close enough. You'll see them at a distance, but it's useful to show a bigger picture just so you get an idea of what they look like. So that's one of the animals that comes ashore and breeds on the Antarctic Peninsula during the summer, and they also breed in the Falklands, and they also breed on South Georgia and a number of other sub-Antarctic islands. And when they come ashore, they generally have 2 chicks, and they're very cute. Yeah, thank you. Yes, the response is fairly usual. They are very, very lovely things, and except, to be honest, when the chicks are getting this big, the colonies, they start off beautiful and pristine, covered in snow, and they dig the pebbles out, make a nest, and lay their eggs, and then the snow gradually melts and melts and melts and melts, and then by the time it's all melted, then it smells pretty horrible. So they're better in pictures sometimes. Another penguin we might see is called a chin strap penguin for very obvious reasons. They've got this black line under the chin, which is very distinctive. So that's another penguin we might see up in the South Shetlands. Maybe if we get towards Elephant Island, you quite often see them in the water there because there are big colonies in the area, and they quite often will just come and jump out of the water and as they porpoise along in big groups. So the chin strap penguin is another one that we might see. One of the other animals that is very distinctive from the oceans around Antarctica, and they breed on the offshore islands rather than on the continent, are albatrosses. And I don't know if anyone's been looking out to sea at the moment, but we've had black-browed albatrosses, which are ones with a white head, white tail, and just a black, dark sort of back and wings. And if you see them sort of cruising along, I've already seen a few from the ship, so they're very distinctive, and I'll show you a picture of black-brown in a minute. But that's a wandering albatross, which we should come across in the Drake Passage. They're well worth looking out for because they're huge. It's like the sort of 787 of albatrosses, and also we may be lucky enough to see a very beautiful grey-headed albatross. This is at a breeding colony on South Georgia where I worked many years ago, and they're rather smaller albatrosses, but incredibly beautiful. And the one thing about albatrosses is their flight. Their flight is just it's like perfection. And the way they fly, I'll do a talk about albatrosses hopefully in a couple of days' time when we leave Ushuaia. So you'll I'll talk a bit more about that. Right, from the fun bit to the kind of, oh no, not politics. Well, interestingly, I think Antarctic politics is actually in a pretty healthy state. Many years ago, in the last century, and Craig will probably talk a bit about this, Antarctica was sort of unknown a couple of centuries ago. Then people started finding it, and the minute humans find a bit of land that nobody owns, they kind of tend to say, ha, this is mine, stick a flag in it. And so that's what all these people did. And as someone who's British, I have to hold my hands up and say, sorry, we were kind of worse at doing this than most people historically. So I'm not blaming anyone for any of this. I certainly haven't got a leg to stand on. And so that was the early these are the early claims to sections of Antarctica. And people started making stamps, British Antarctic Territory, and Sir Douglas Mawson Centenary. That was the Aussies, I think. These are French, a very Frenchy sort of stamp, and that's an Argentine one, and that's a British one there with the Queen on. And so people started getting very sort of, up to with politics. And then in 1957 and 58, that summer season. All the people who worked in Antarctica, all the scientists, good for them, said let's all work together for a season and we'll see if we can do some collaborative research. So they all started working together, and the results of that cooperation and collaboration were so good that they thought, well, look, this is, we've got to be really careful about what happens to Antarctica. If we let some of these national claims go ahead, people might start coming down and digging for, lithium or copper or something, or doing this, or fishing it out and killing all the whales again, which already had happened around South Georgia. So they started talking a bit about the politics, about how Antarctica should be run, and how the whole world was responsible for this one place. And so they came up with the Antarctic Treaty. And the Antarctic Treaty basically was signed in 1959 by 12 countries. Which actually has now been signed by 53 countries from around the world. They all agree that there should be no military activity at all in Antarctica. There should be no land claims recognised. All those land claims that were made in the early parts of the 20th century, they're suspended, but they're not recognised. So no one owns Antarctica. In 1991, there was a kind of environmental protocol about how to behave down there, because there were more people turning up doing science. There was an increase in tourism, and so they agreed on no mineral exploitation at all. And they also agreed there should be protocols for tourism as well. So this became a kind of international agreement to look after Antarctica and treat it well. The original signatories to the Antarctic Treaty have their flags in the middle there, and you'll presumably recognise some of those, and then all the other nations who've joined subsequently have their flags around the outside. And so there's now a really good international agreement that it's an international territory, and anyone who works there is doing it for the benefit of Antarctica and mankind, or womankind, I should say, or anyone kind, really. So that's what happens at the moment. So, as I say, who owns Antarctica?
No.